Here we have the function x squared plus 3x minus 4 over x minus 2. Find the vertical asymptote. Well, that is when the denominator is equal to 0. So the vertical asymptote is x equals 2. The axis intercepts, let's find the y-intercept first. That is when x is equal to 0. So we get left with minus 4 over minus 2, which means the y-intercept is 0, 2. The roots are when the function is equal to 0. So that's 0 equals x squared plus 3x minus 4. We can solve that by factorizing. It's going to be x minus 1 and plus 4, which means our roots are going to be at 1 and minus 4. Find the oblique asymptote. To do that, we need to find the quotient when we perform the division. So we're dividing by x minus 2. We know we get x squared, which means that has to be x, which means that is minus 2x. But we want 3x, so we need 5x here, which means we have 5, minus 10. We need minus 4, so the remainder is going to be 6. But we don't actually care about the remainder. All we care about is this quotient. So our oblique asymptote is y equals x plus 5. Putting that all together, we can try and sketch the graph for a big set of axes and put in our asymptotes. We said the vertical asymptote was at x equals 2. The oblique asymptote is at x plus 5. It's going to come down somewhere through here. Going through 5 and minus 5. I think let's try and get the scale a little bit better there. If that's minus 5, then 2 is going to need to be a little bit closer. Let's say 2 is about there instead. Make the scale a little bit more accurate. And then we had some roots and a y-intercept. The roots, the y-intercept, let's do that one first, was at 2. So it's going to go through here at 2. And the roots were at 1 and minus 4. So it's going to go through here at 1. It's going to go through here at minus 4. So given that, it's going to have to approach through here. It's going to approach the asymptote from there. It's going to come up and then down and then quickly go down. I'm going to approach that one. There's going to be a second part to this graph, and it's going to have to be in the opposite corner, like rational functions always are, which means it's going to be up here and going to approach that asymptote from that side.